All right, so let me do this question. Again, I'm trying to backfill a lot of homework helper videos that I wasn't able to have available for you at the beginning, earlier in the semester, because I had a ton of new questions. This question I thought should be easy, but let me first to read and make sure I didn't miss anything when I was just picking this out. It says a bullet shot from a rifle. We are given its mass and then some speed. Oh wow, 340 meters per second. That's the speed of sound. Do bullets travel that fast? Maybe. It strikes a target. Okay, so there's some sort of target here. A large bag of sand penetrating. So I think we are invited to assume that when the bullet is starting to strike the sand bag, that its initial speed is basically the muzzle velocity. In reality, it might not be, but here, to make the problem solvable, we're gonna assume that. And we are told it embeds itself some distance, 0.36 meters. So let me call that delta x. And here now V final should be equal to 0. And the question is asking, find the magnitude of the force that slows and stops the bullet. And I guess we are looking for some sort of kind of average force, or assuming it's constant force. So here really all we need to find is what is the amount of acceleration that's slowing down the bullet. Once we have that, then we use Newton's second law. Net force is equal to mass times acceleration, and that should be it. And with all the information that's given in the question, I think through kinematics formulas in my head, because really in trying to find the acceleration, kinematics information is what we are given. And one formula that's quite often useful, so it's actually one of the first things I would try, and here it works, is the V squared formula. V final squared is equal to V initial squared plus 2 times acceleration times delta x. Remember, these are kind of like vectors. If they're in opposite directions, it's supposed to be negative. The product is supposed to be negative, and you can do that by making one of those numbers negative, like acceleration is going to be negative. Let me solve that for acceleration. So my acceleration is, doing that in my head, done it many times, final velocity squared minus initial velocity squared divided by 2 times delta x. Here the final velocity was 0, so it's really 0 minus initial velocity squared divided by 2 times delta x. I think all the numbers are in basic SI units, or I can easily convert to basic SI units. So let me do that. Initial velocity is 340 meter per second. So I'm just gonna keep everything in basic SI units and just not put in any units in the Wolfram alpha. So 340 squared divided by 2 times the delta x, 0.36 meters basic SI units. So this is the, oh wow, is it really that big? So 340 squared, yeah, that seems large, but that's probably right. So that's my acceleration, and once I have my acceleration, then I can multiply that with the mass to get net force. So let me just multiply this with the mass. I'll just convert from gram to kilogram on the fly, you know. I can do it this way. Times 18 divided by 1,000 for conversion from gram to kilogram. 28.90 Newton. That feels large, because that's enough force to lift a 289 kilogram person. I don't know. I don't know much about bullet ballistics dynamics. I don't know if this is a reasonable amount of force. Although the numbers here seem 36 centimeter. Yeah, I think I've like on YouTube videos with people shooting stuff and whatnot. I think I've seen something like this on a ballistics gel. So that's a large amount of force. I guess that's why bullets kill. Yeah.